Hey guys, welcome back. In this video, we will be covering the derivatives of some common functions, which would be very helpful going forward. Okay, so there will be a list of common functions for which we will be listing out the derivatives. Okay, so let's start with that. So our first is the derivative of x raised to the power n, that is d by dx of x to the power n. So every time we mean derivative, we will be mention it using d by dx. So currently we are differentiating with respect to x, so dx, right? So we will be using d by dx in place of derivatives. So d by dx of x to the power n is n times x to the power n minus 1, where n belongs to the domain of real numbers. Okay, so this is our first rule. Now, second is very often used, that is d by dx of a is equal to 0, where a is any constant function. That is, value of a is not changing with respect to x. Like fx is equal to 1 or fx equal to 2, fx equal to 3. That is any constant number. So d by dx of a constant is always 0. Now the third one is multiplication of above two functions. That is d by dx of a multiplied by any function. That here a is the constant and fx is any function dependent on variable x. So now we can take here the constant out of the differentiation. This could be verified by using the product rule of differentiation. Hence it will become a multiplied by d by dx of f of x. So we always take the constant out of the differentiation whenever it's in product with a function. Now the fourth rule is d by dx of sin x is equal to cos x. This we have already seen when we were calculating derivative using the first principle of derivative, where we found that d by dx of sin x is equal to cos x. Similarly, you can prove the other derivatives also. Like d by dx of cosine x comes as minus sin x. So you can prove this also using first principle of derivative. And I encourage you guys to try it yourself to prove these results. So next one is d by dx of tan x. This is equal to sec square x. And we know that sec x is equal to 1 by cos x. Now the next one is d by dx of d by dx of cosec x, which is reciprocal of sin x. So the d by dx of cosec x is equal to minus cosec x multiplied by cot x, where cot x is the reciprocal of tan x. Now the eighth rule is d by dx of sec x. So d by dx of sec x is sec x multiplied by tan x. So next one is d by dx of cot x, which is equal to minus cosec squared x. And the next rule is the 10th rule is d by dx of ln x. This is equal to 1 by x. And the 11th one is d by dx. Now in here the ln here is log base e, right? This is ln x is equal to log base ex, where e is a natural base which is generally equal to 2.71 approximately. So normally when we say log x, the base is 10, but in ln x the base is e, and e is equal to 2.718 and so on. So this thing is written as ln x. So d by dx of ln x is equal to 1 by x. Okay. Now the next one is d by dx of a to the power x. which is equal to a to the power x times ln a, where a is any real number and it is greater than 0. So this condition should hold in order for this derivative to be defined. So now the last common function which we will take is d by dx of e to the power x, where e, as you know, is the natural base and its value is 2.718. So d by dx of e to the power x is e to the power x itself. So only this function has its derivative exactly similar to itself. So derivative of e to the power x remains the same as e to the power x. So these were some common function derivatives, like these were some common functions whose derivatives you should remember, as these comes very handy while solving any problems like we saw in the L'Hopital rule for evaluating limits. Okay. So let's take some examples based on these rules. So let's start with our first example. So guys, if you remember, those rules which we just defined, that will be really helpful while solving problems related to these limits and derivatives. So now without any further delay, let's start with our first example, which is d by dx of a to the power x multiplied by sine x. So let's say this is our first function f of x and this is our second function g of x. Then this is multiplication, right? So we will be applying the product rule here since two functions are in multiplication. And as per the product rule, we have first function multiplied by d by dx of the second function plus d by dx of first function multiplied by second function. Okay, so now let's substitute the values of f of x and g of x. So fx is e to the power x and g of x is sine x plus d by dx of a to the power x multiplied by g of x, which is sine x here. So this is a to the power x and d by dx of sine x is cos x from the previous rules, right? Plus d by dx of a to the power x. From the rules mentioned earlier, this is also, we can derive from there that it is a to the power x times ln a and multiplied by sine x, which is here the second function. So the result becomes after taking a to the power x common, we get cosine x plus ln a, and this is ln a sine x, right? So here we have used two things. One is the product rule and the other is the derivative of some common functions like sine x, cos x, and the derivative of a to the power x. So this was our first example. Now let's take a look at another example where we will be using the identities and the algebra of derivatives. So let's say our second example is something like we need to find the derivative of ln x divided by tan x. So we have to calculate the derivative of this function. So we can consider this function as f of x and this as g of x, where f of x is the numerator function and g of x is the denominator function. So as we can see here that these two functions are in division. Okay, so we will be applying the quotient rule in this example. So now let's apply the quotient rule. So as you guys might remember that the quotient rule is d by dx here d by dx of ln x over tan x. So the quotient rule will be denominator multiplied by d by dx of numerator, that is d by dx of ln x, minus numerator multiplied by d by dx of denominator. So that is tan x here. And this whole is divided by the denominator whole square, that is tan x whole square. Okay. Now this is tan x multiplied by d by dx of sin x, which you guys remember from previous mentioned identities, that is 1 by x, minus ln x. Now derivative of tan x is sec square x, right? So this is sec square x, and this whole is divided by tan x whole square. So this is our answer. So these were some basic examples which were covering the application of the algebra of derivatives as well as the derivatives of some commonly used function. So I hope you guys might have understood this lecture, and so see you in the next video where we will discuss about the chain rule. Thank you.